Hi guys, hi, I'm Divakar Kushwaha and welcome back to again my YouTube channel called VDK. So once again, so in previous session in Python we discussed about the object-oriented programming system. So let me give an overview of this previous one. Right. So OOPS basically stand for object-oriented programming system. Object is instance of any particular class. I mean, without class, you cannot imagine any object. Without object, you cannot imagine any classes, right? Both are depend to each other. We discussed already. So we say everything is object. So how we can identify this is an object, right? This is really very complicated for user because in simple word you say in this word everything is object, right? So how we can prove that this is an object? So object have a three property. There are three property of an object: state, behavior, and identity. In short, it is called SBI. Okay, clear? So any object state and behavior can be same, but identity will never same. Identity always going to be unique. I've discussed the different example in the previous session, right? Like suppose in the classroom there's a student, right? So student name can be same, student program can be same, but student ID always going to be different. Student ID never going to be same to same, right? So everywhere is any object state behavior can be same, but identity always going to different. So another one we discussed the pillars of hopes, like how hopes depend upon on it, right? So hopes depend upon the pillars. What are the pillars of them? Like polymorphism, inheritance, abstraction, and encapsulation we discuss. Right. So we are on the polymorphism. What do you mean by polymorphism? In polymorphism, like poly plus morphism, I mean there is one object but existing in different form. Right. Polymorphism was derived from the Greek word. There are two types of polymorphism, right? Like I told you in previous session, guys, like poly plus morphism means there is one object but existing in different form. That is called polymorphism. Okay. So static polymorphism, that is called function overloading. Dynamic polymorphism, that is called function overriding. So which is over here. So today's session we are going to continue from here. Dynamic polymorphism. Dynamic polymorphism or function overriding. Function overriding. Okay. So if somebody say dynamic polymorphism, so dynamic polymorphism is function overriding. If somebody say static polymorphism, so it's called the function overloading. Okay, guys. So clear there are two types of polymorphism, right? Clear. So next we go for the function overloading. Okay, overriding. I should be okay. So what happened in the function overloading? Basically, in function overloading, function name should be same, but number of parameter going to be different. Like very simple example. Suppose I make a function here dks, right? Here I define the function in Python. Def keyword we have to use it for define the function. I discuss dks, and here I given like parameter like integer string. Okay, and here should be a statement in the print. Okay, like a program statement, program statement. Fine. So again here I'm going to make another function. So def, see my function going to be same to same. Do you get my point? Function going to be same to same. Dks. Here suppose I take float and here integer. So this is way we going to display. So everywhere function name should be same, but number of parameter going to be different. That is called function overloading. Okay. What is called function overloading? Like suppose you have only one laptop, like very simple example, right? So suppose your function is a laptop. So in one laptop you can install rest of the software like a Python, right? Panda libraries, Excel, Power BI, Tableau, any particular one, right? So laptop is only one. It's not does me like for each of the technology you are buying different laptop. Not possible, right? So that is why like your laptop is only one, but you are loading different kinds of program inside it. Clear? Dynamic polymorphism basically based on the inheritance. What do you mean by overriding? Overriding means suppose things are existing, right? But you just override extraordinary feature. Like very simple example, like a laptop previously also existing, nowadays also existing. But previously laptop was like a look like a board. Nowadays laptop like slim and fit, right? Nowadays laptop have touch screen feature. Nowadays we have a wireless keyboard, wireless mouse, right? So keyboard is keyboard, mouse is mouse, but the feature override extraordinary is just wireless, right? Clear? So property already existing, we can only override on it. Fine. Same like that. Like very simple example, I told you follow the inheritance concept. Like very simple example, if we talk about the inheritance like grandfather property inherited by father, father property inherited by own son and daughter. So what happened? This is called the generation by generation property transformation, right? Means property was only one, right? People accessing generation by generation. That is called reusability basically. So inheritance, what is the advantage of this? Reusability concept means suppose I have only one code, same program I can use number of attempts. Like very simple example, guys. Another one. Like you have suppose in your home you have a laptop. The same laptop accessed by you, your brother, sister, any family member, but only one laptop, but everybody can use it. Everybody can walk, right? Suppose in family there is only one car. You can drive. Sometime father can drive, mother, any family members can be drive. So there's only one car, but everybody can use. So only one object, but everybody are using. So that is called reusability concept, basically in a inheritance. Okay. So that is called overriding. So suppose son inherit property from father, right? So obviously son have to do the overriding on it, right? He have to develop some extraordinary feature on the property, right? Not it's not should be like you destroy the property which one you taken from father. It's not should be like that. So inheritance like we have a parent class and child class. Parent class. There are two types of class here. Parent class and second one is a child. First one, parent class. Parent class also known as a super class. What is it? Super class. Super class is also known as a base class. Okay. Second one is called child class. Child class is known as a subclass. Okay. Sorry, it should be small. Okay. Child class also known as a subclass. Okay. It's also called derived class also. Okay. So here's a parent class and child. So child class always inherit property from parent class. Is also derived a property from parent class. That is called inheritance. So inheritance advantage I told you, right? Inheritance like a parent class and child class. So child class always inherit property from parent class. Okay. So after that we are going to discuss like a single level inheritance, multi-level inheritance, and hierarchy level inheritance. This is the types of inheritance we're going to discuss here. Okay. Next one, you going to be like abstraction and encapsulation. What do you mean by abstraction? What do you mean by encapsulation? Abstraction means showing essential value, right? Like very simple example. Suppose you have a laptop and you are doing Python code on the like PyCharm, Jupyter, any particular software, right? So my abstraction part, my requirement is I want to write the code on it, right? That is called abstraction, right? Encapsulation always hide in the back. I mean, like very simple. Abstraction and encapsulation working together. I mean, without abstraction, you cannot do the encapsulation. Without encapsulation, you cannot do the abstraction. Encapsulation word basically derived from the capsule medicine. Which medicine? Capsule. Like have you seen the capsule medicine? In capsule medicine, guys, there's a lot of elements already filled it out inside, right? So once person sick, person can simply take the medicine, feel better. But it's not like that. They open that and after open, they just see what is inside. Not like that. Like very simple example, like a fan. So fan, there's a wire and condenser always hide in the back, right? Suppose if I remove the wire and condenser from the fan, it will work? Definitely not. So encapsulation always encapsulate hide. So abstraction showing the always essential value, encapsulation not showing the essential value, right? It will always hide in the back, right? It's always in the wrap up in the back, right? Okay. So next, abstraction encapsulation, they always like laptop, like very simple laptop, all the hardware components, like a motherboard, hard disk, SSD, always hide in the back. It's not like that every time you open the laptop and you see, right, where is motherboard, right? It's always hide in the back of the laptop. You get my point? So abstraction, obviously, if you remove the motherboard, can we access my laptop? Definitely not. So abstraction and encapsulation always working together. I mean, without abstraction, you cannot perform encapsulation. Without encapsulation, you cannot perform abstraction. Okay. So I hope you guys understood till here. In next session onwards, we are going to do the practical, how to create a class and how to make object of the class and how to call rest of the property and member with the help of the object. Okay. So theory parts we cover up in the hopes. Next session onwards, we're going for the practical. Okay, guys. Thank you so much. And then see you in next session. Take care, everyone.